Hi there, my name is Ron Rogers, and this presentation is titled Flight Testing the Airbus A330. Now, this is part two of the flight test I went over to Airbus back in 1993, the end of, because they needed somebody from the Airline Pilots Association. They needed a reporter. And I had talked about this in my previous thing about we had a discussion that if anybody was going to fly an airplane and report on it, it should be somebody from our committee. And when I had been a member on the committee, we really didn't get to flight test much of anything. They didn't really care to give us any flight time. But when the issue came up where they're getting free press, now everything changes. And the interesting thing, this was the second article I published. And there it is in the Airline Pilots Association magazine, free publicity, about 80,000 circulation. And you see, flying the A330. I made the front page this time. Last time I was just, kind of inside there, and I'm on page 16. So, hey, I'm doing pretty well on this. This worked out to actually be a pretty good idea to get us some flight time as a committee in the aircraft, and we had not been getting this, which just didn't make any sense. But the manufacturers were just not going to give us any flight time, and these articles were like a calling card. We got all the manufacturing people asking us, would you come over and fly our airplane and write a report about it? So that started a really fun time and adventure for the committee where we got to do a lot of really good stuff. And this is the article. I'm going to put a link down below so you can hopefully download the PDF file if you want it. And one of the things Airbus does is they put together this nice little briefing brochure telling you about how their airplanes are the best thing since sliced bread, and they're more efficient than everybody in the world, and all the good stuff. It's typical marketing stuff. And so I got a fairly nice spread in the magazine with the discussion of the various aspects of the A330. And it's kind of fun to fly a flight test aircraft because you get to do a lot of things that you don't get to do in an airliner like this, let me tell you. And any Airbus pilots watching this, you're going to really enjoy some of the speeds and maneuvers I'll talk about here because pretty darn dramatic. But again, this is flight test. This is stuff you don't typically see on a passenger aircraft in normal service. If you did, you would get so many nasty letters that you would probably never fly as a crew member again. So here we go. Now, the A330, they're pushing me back here. I'm in the left seat there. This flight evaluation was about I think a 2 hour, 17-minute flight, but the A330 is about the size of a DC-10-10, except the 330 is 27 feet longer and has a 42-foot greater wingspan. The 330 has a maximum liftoff of 467,400 pounds, and we weighed 330,000 pounds, mainly because we didn't have anybody on board. So we were fairly light, so we got some reasonably good performance. And for our weight, our V1 and VR were 131 knots indicated, and a V2 was 136 knots indicated. Now, the protections were a little more advanced so far in this aircraft, advanced as far as development of the protections. All these aircraft, each individual aircraft, the flight control computers have to be tweaked for that aircraft. They'd like you to think that it's one box, you could swap it everywhere, but no, they're specific to the airplane because you still have to tailor it to the individual aerodynamic characteristics of the aircraft. Now, this one had the tail strike protection active. So it wasn't like on the 321 where I had to slowly rotate to 10 degrees and wait for it to fly off. This one I could do the normal 3 degree per second rotation that you do in airliners up to a 15 degree pitch attitude and take off. Now, of course, being a flight test aircraft, they told me that my rotation rate was 2.7 degrees. And actually on the 777, at least the Dash 300, they'll tell you what your pitch rate is, so you get an idea, how you're doing, so you don't rotate too rapidly, because you don't want to rotate too rapidly and have the possible danger on most aircraft of hitting the tail. So you go for 3 degrees, and of course most people do a little bit less than that, so they make sure they're within the boundaries. So we took off and cleaned it up, and now we're climbing on out. We're climbing up to the test area, and I played with the roll response, and I found it very nice and effective. I put some rather large rolls into the aircraft to kind of check out the spoiler activation. Now, the one thing interesting about it is you don't really want the spoilers to activate unless you really need them, and they have very good roll response in this aircraft. So I was able to roll in quite a bit side stick before I actually got any spoiler activation, which is a good thing. So we're climbing on out on this. So I'm passing flight level 320 with a climb rate about 2,200 feet per minute, and passing 350, we're down to 2,000 feet per minute, and I'm 270 knots at 0.8 Mach. Now I leveled off at flight level 370, and now this is something you don't do on a normal airliner. It's a flight test airplane. I pulled full back stick and performed bank-to-bank rolls. Now, because you're in a full aft stick, high AOA situation, it limits you, the protections, to 45 degrees of roll instead of the normal 67 degrees of roll that you would normally have. So, okay, that was fun. That was fine. So let's climb on up to 410. That's the maximum certified altitude for the aircraft. And, of course, being a flight test aircraft, that doesn't mean too much. I mean, it doesn't mean we have to stop there like you would on, if you were flying a certified aircraft, because other than that, you'd be violating, the limits on the aircraft. So we're climbing through 390 at 270 knots indicated, and I've got a fuel flow about 7,000 pounds per hour per engine. Passing 410, flight level 410. Again, I pull full aft stick, and I rolled left to right, and I rolled into a 45-degree bank angle then, and just held it. And as I rolled back into a 30-degree bank, the airspeed was decreasing to 220 knots, and we were climbing at 1,500 feet per minute. Now, in this, we continued to slow, because the airplane really didn't have the capability, thrust-wise, to keep on going the high altitude. So we got down to 207 knots, The aircraft was still full aft stick. Now it starts to descend because it just can't maintain this performance. And once again, the aircraft in normal law will not allow you to stall. So I can sit there at the maximum certified altitude, pull full aft stick. The thrust comes in automatically because you trigger alpha floor protection. And I can sit there in a bank and just hold it until the aircraft kind of runs out of oomph and just starts to descend. So when I got down to 390, decided just to reduce the back stick and let the aircraft accelerate. All right, enough of that fun and games. Let's look at the high-speed range. So to take a look at that, I decided, well, let's do emergency descent. I mean, it wasn't that I decided on the spot. This has all been pre-briefed, and the pilot, the test pilot I'm flying with, Airbus test pilot Pierre Beau, the one who's famous for saying that they build an aircraft that pilots can't crash. Of course, this was early on in the program with the Airbus, before people started crashing the airplanes on a reasonable regular basis, finding a few holes there. But okay, let's do an emergency descent. So I gently push the stick full forward and hold, and the aircraft pitches down to about 4 to 5 degrees nose low. And the initial descent rate was 2,700 feet per minute. Of course, the engines are at idle. And I extended the spoilers initially to 1/2, and it increased the descent rate to 4,800 feet per minute. And Buffett was fairly mild, and Pierre Beau stated that for passenger comfort, that was pretty much where they would limit the speed brakes for a normal descent, because after that you start getting a lot more buffet. but we don't have any passengers other than the flight test engineers who are used to all this wild stuff as it is. And so I'm going for full spoilers. So when I go to full spoilers, we get 5,300 feet per minute passing flight level 350. Going through flight level 320, now we're up to 6,000 feet per minute. And the VVI, the vertical velocity indicator, changes to yellow now because it says, this is a pretty good rate going down. You're in kind of the caution range. You might better be aware that this isn't kind of how we like to normally operate the aircraft. So it's a little bit of just, an indication. So now I'm going past flight level 300 at 300 knots, and I've got 7,000 feet per minute rate of descent. And I went up to 330 knots, passing 250, and I retracted the speed brakes, and the descent rate decreased to 3,100 feet per minute, but I'm still holding full forward stick. But the aircraft, the computers, they adjust the pitch attitude to maintain airspeed so we don't overspeed. But we reached 340 knots indicated at flight level 220 with a descent rate of 5,200 feet per minute. And now we're receiving the oral overspeed warning and the red indication because it says, yeah, this is not what we want you to do. You're overspeeding the aircraft. We're down to 15,000 feet now. We level off there and decided to explore a little bit of the nose high performance capabilities with the ALPA floor type of protection. So we're going to look at the low speed handling characteristics. So I'm at 105 knots now, 22 degrees nose up, and at this point the computers activate the ALPA floor protection. So the engines come roaring in. We start climbing through 12,000 feet. We're going up at 4,500 feet per minute, full back stick. And now the airspeed is 95 knots. And for any of you airline pilots out there, or even small airplane pilots, 95 knots is kind of a slow speed no matter what you're in. And we're climbing at 5,000 feet per minute at 95 knots. And, this is a big airplane, size of a DC-10. So this sucker's big. So 95 knots is an interesting airspeed. And we stabilize finally at 90 knots, climbing at 4,000 feet per minute. Then I cleaned up the aircraft and we went through a hydraulic failure simulation of the blue. And Airbus labels their hydraulic systems in colors. And the procedures, and this is what they're going at, commonality between the airplanes. The procedures were actually fairly identical on how we handle that type of failure situation. So now we're going to look at some control law reversion. So we asked our flight test engineer, Fernando, to put us in direct law. And when I went through Airbus training at United, they said, wow, how do you get into direct law? And the answer is multiple system failures. But I said, oh, it's easy. We just asked Fernando to put us in direct law. And he goes back there at his flight test station and he does it. And they go, no, that's not the right answer. You don't have Fernando on this flight. But anyway, I digress. So, okay, we're going to look at that, and the aircraft handles fairly well. Now, the interesting thing about the flight controls, in direct law, you have direct stick to a flight control surface, and the max roll rate of the aircraft, all of them, the Airbus series, is 15 degrees per second. Okay, so to get 15 degrees per second in all phases of flight, you need a natural roll rate higher than that. So the natural roll rate is up like 20 degrees. And the roll rate is very crisp. There's a tau function, which is the rise, the rate of roll as you put in stick. And it is very crisp. Now, this isn't a fighter. It's not an F-104, but the only other airplane that had, kind of similar characteristics of a very initial crisp aileron roll is the 104, because that thing really takes off. And you can take the other pilot's head and bang it across the canopy, obviously in the two-seat F-104, not the one-seat. You can't do that unless you like to bang your own head against the canopy. But the roll rate is so rapid in that airplane that you can bang your head against the canopy. But I digress. Oh, I'm working on a T-shirt. I'll show you a picture of the T-shirt in my next presentation, hopefully, and I'm trying to get that thing squared away of the "But I digress" T-shirt. Anyway, where was I? Okay, we're talking about the reversionary controls. Okay, we did that, and everything's fine. But to get, as I was talking about, that higher roll rate, you have to have a natural high roll rate. And when they put the flight control laws in there, they kind of smooth that out. So it's a more normal control rate with a nice approach and decay, so you're not bouncing everybody around the airplane, because that would not be desirable. And I talk in another presentation about how we'd go out when we'd fly, out at Toulouse and have nice dinners. And in Vino Veritas, you get the pilots talking, and came out that, well, why is it 15 degrees per second maximum roll rate? Well, at one time on the Airbus 320, they had 20. And during some flight test activities, they got in a very serious PIO, pilot-induced oscillation, because in the flare, when they had a roll rate of 20 degrees per second programmed in the normal control law. So they backed it to 15, and they didn't have any recurrence of the PIO issue there. But okay, now we're coming in to land, and the reason I've got this picture here is that the 330 has what's known as dual bogey gear system. That's the two gears front and back, kind of like a 767, but they slant them the other way for you 67 pilots. Or as John Cashman called it, we got it right on the 777, we got it backwards on the 767. But okay, I'm coming into land, and there's quite a bit of difference between those two gear, and it's kind of cool because I touched down on the rear bogies first. Obviously they're lower, and I'm derotating the nose. We came in on a practice single engine pattern, I think was the first one. So my first landing in the 330 is a single engine practice single engine approach, which is kind of fun. But the airplane flies very well. But okay, I touched the main bogies down first, and now I'm derotating. And then I get the nose down actually quite a bit, but what happens is now the front bogies touch down. Well, I'm thinking, because I'm used to flying a single bogey aircraft. I was on the, I think the 727 at the time, or even the 737. They have single bogies. So when I felt that second touchdown, I thought, oh, that's the nose gear, and I relaxed the stick, and about 5 feet later, when the nose rotated a little bit more and the nose gear comes banging down, I realized, nope, that wasn't the nose gear. So that was a little lesson that I'm sure all you A330 guys out there, now that the airplane's been out for decades, are just laughing at me about. But yeah, I learned that lesson pretty quick. Now, one of the main things Airbus is going for is commonality of aircraft characteristics, cockpits and that, so it is an easy transition. I flew the 319 and the 320, and United didn't have 321s at the time, but I could have flown that on the single type rating because the aircraft are so similar. And really, you can go in the cockpit of a 330 and it looks almost identical. You go in the 340 and it looks almost identical also, but you got two extra thrust levers there. So that, of course, points it out right away, but there's a lot of commonality. And Advisory Circular 120-53, which ALPA had a lot of input in there, talks about what Airbus has called cross-crew qualification, the ability to train in one aircraft and easily transition to another. Now, they did a good job here because, Boeing keeps stretching the rubber band on the 737, from the 100, the 200, the 300, the 500, the 700, 800, 900. I asked them if they're going to call the next one the 1100, but they went to talking about MAX 8, 9, and 10 and stuff like that. But it's still the same cockpit where you can hit your head on those little knobby switches that stand out there that I always do when I walk in. And I said, Boeing, I said, you can only stretch the string so long. You might want to start with a fresh sheet like Airbus did, because they're going to eventually just kind of clean your clock, which for different reasons, they are kind of cleaning Boeing's clock right now. But Airbus makes a good airplane. I've been very critical of the flight control design, and I still have my reservations on it, but they do build a good aircraft. So that is my discussion of my second flight evaluation on the Airbus aircraft, the 330, and I have a lot more of these coming up. So I'll take you through my whole adventures in flight test, and I got to fly a bunch of interesting airplanes. I got to fly turboprops, ATR 4272, the de Havilland Dash 8-400, the Saab 340 and Saab 2000, and even got to do an evaluation on the C-17 because McDonnell Douglas was trying to sell it commercially as the MD-17. But that's another story. Sort of digress. Anyway, I hope you found it interesting and informative, and thanks for watching.